All right, my growth mindset. Math side, maniac, Panthers. Here we go. Let's finish this lesson on least common multiples and least common denominators. Remember factors? Factors are finite. They have a stopping point. They don't go on forever. There's only so many factors. But multiples are infinite to infinity and beyond. They go on and on and on and on. Can you find the greatest common multiple? No, it would be infinity, no matter what. Even that doesn't really work when you get into math theory. So you just can't do it. It's not, there's really no such thing. Can you find the least common factor? Least common factor. Does that actually work? It would always be one. Every time you find the least common factor, it's always going to be one. Is that really helpful? I don't know. I don't think so. So anyway, let's do this. We're finding least common multiples and greatest common factors. Makes more sense when you think about it. So speaking of which, this is where we left off in both classes. Select all pairs of numbers that have the least common multiple. So yeah, come on now, let's do something. Let's go. I'm trying to click you to the next slide. There it is. Here we have 3 and here we have 8. And I don't know why this just popped up. Maybe it can go away. Go away, please. There's an X right there. Thank you so much. A little glitchy start here, but we're going to roll it out through this. We're going to iron this out. So we got 3 and 8. We got 3 and 8. What's the least common multiple? So these are the ones we have in common. And we're trying to, oh, that is 24. So we're looking for the pairs that have 24 as the least common. So here's 24. They have that in common. Do they have anything that's less than 24 in common? No 8s, no 16s. No. So this is an answer. This is a valid answer. A is one of their answers. Yay, if you pick A as one of your answers. Is there more than this, though? Let's find out. Oh, here we go. Clicker. The clicker is quicker than me trying to do whatever it is I was just trying to do. How about 8 and 12? 8 and 12. Let's see. 8, 12. There's our 24 here in common. Anything below that in common? Nope. There's another correct answer. Yes, 8 and 12 have the least common multiple of 24. 3 and 8 have the least common multiple of 24. How about C? Let's check that one out. Here's our 3 and 4. And here's our 24. Anything less than 24 in common? No 4s up here. 8s, no 8s, no 12s. Uh-oh, spaghetti-o. There's a 12 and a 12 here. So that's less than 24. So guess what? C doesn't work because it says, is 24 the least common multiple? It's common, but not the least common. Okay, what about this one? 6 and 8. 6, 8. There's our 24. Anything less than that? Anything in the blue here that's the same? Nope. So that's also an answer. So I think we said A, B. Didn't we say B? And D, but not 3. Not this one. Let's make sure I got that right. Yeah, not 3 and 4. Ta-da! Now, that was the least common multiple of 24. Let's do the least common multiple of 8, 4, and 6. All 3 of them? Is that possible? It is. I cheated on this one. I Googled it and screenshot it and put it right here. Here's the 8s. All right, so here's our, oh, it just happens to be 24. That's a coincidence. I didn't do that on purpose. Is there anything less than 24 in the blue here that's the same? Nope, not for all 3 of them. I do see an 8 here and an 8 here, but not here. So that's not going to work for 8, right? I see anything else? I see a 12 here and a 12 here, but I don't see a 12 here. So that's not going to work. It has to be common for all 3 of them. So this would be the least common multiple is 24. But let's take these same numbers and find the factor. Remember, see, these multiples go on forever. That's what these dots mean, forever. So you're going to find the greatest common multiple? No, it go on forever and ever. It's infinity. What about the greatest common factor to these? So let's put out the factors. 8, you have, it always starts with 1, right? And it always ends with whatever it is. So 8 ends with 8. 4 ends with 4. 6 ends with 6. And then you got what's in between. So what's common here? is 2. That's it. So pretty small number. If you look at multiples, the answers are usually pretty big for multiples because they go on forever. But factors, the answers are usually, trying to get it to switch for me here. Oh, it's not responding. And oh, went too far. Here it goes. The factors are usually smaller. Like here you have 8, 4, and 2. What's the greatest common factor? You would think great means bigger, but nope, it's 2. It's actually smaller than these numbers that we started with. What about multiple? Multiple is bigger than these numbers that we started with. Okay, let's go on to see what's next. Lowest common denominator. What? What happened with multiple? We were doing lowest common multiple. Now you're talking about this denominator stuff, Mr. Hoffman? Whatever happened to lowest common multiple? Which really the same thing, but we're looking for the lowest common multiple. It is, but we're looking for it in a specific place. We're looking for it in the denominator of a fraction. So here, look this way, right over to the right. See this denominator 3 and 4? What's the lowest common multiple of 3 and 4? That's all we're saying. And we know how to do that. Look over this way to your left. I'll highlight it in a color I don't have highlighter yet. No, yellow, green. We're looking for 12. See, 12. 12, there it is. So it's 12. So this is also 12. So what about 4 and 9? Right? Here's our 4, here's our 9. It's 36 because 4 and 9 makes the 36. Lowest common multiple of 4 and 9 is 36. Lowest common denominator of 4 and 9 makes the denominator 36. The idea is that what we would do is we would change this denominator to 36. We would change this denominator to 36. But if we change the denominator, yeah, you probably know where this is going. We're gonna have to change the numerator to balance it out, right? So whatever we multiply 4 by to get 36, we're gonna have to multiply 9 by, I'm sorry, we're gonna have to multiply the top 3 by that same number. And then whatever we multiply 9 by to get 36, we're gonna have to multiply the top number to get that same number. I wanna go into this a little bit more soon enough to help you visualize that a little bit better and why that works. Let's just look at this one. So 3 and 9, 3 and 9. Oh, this is interesting because 3 and 9, the least common denominator, or even for the least common multiple, is 9. Did you notice down here, when we did 3 and 4, it's 12? Right down here, guys, down here at the bottom. What's 3 times 4? It's 12, so that actually works there. 4 times 9? 36. But 3 times 9 is 27, but that's not the lowest common denominator. The lowest common denominator is actually 9 when you write it out. So it's just something to notice. It's not always, you can use that trick where you kind of multiply the denominators, like 4 times 9, oh, 36, 3 times 4, 12. 3 times 9 is 27. Now, you could probably do the problem with 27, but it's going to be a lot harder. It'd be so much nicer if you did it with 9. Just saying. Okay. So we're going to skip definitions here for a moment. Take a look at this. 1 times 1. I know you got it before I could even like finish saying it, right? Before I even started saying it, you probably got that. How about 2 times 1? Okay, 3. 100 times 1. 100. 1,000. Oh yeah, smarty pants. Try this one. 1,023 times 1. Try that. Oh, yeah. Okay, you're right. Sorry. Thought it was going to be a little bit more challenging. It's not. Hang in there. We'll get there. Oh, how about 1/2 times 1? Try that one, smarty pants. Oh yeah, 1/2. Right. 1/6 times 1. Yeah, 1/6. 1/2 times 1. Oh, did I already do that one? Why did I do it twice? I'm not really sure. We'll just put it in there. Okay, so you get the idea, right? This is going to be so useful when we go to the next level. You ready? You ready to take it? Oh, I already did. I took it to the next level before I could even finish. Are you ready to take it to the next level? Come with me. Let's go to the next level. So a factor is a multiple by 1 and equal to the product. What? A factor multiplied, oh, I didn't put applied by 1 is equal to the product, right? So 1 is equal to 1. 2 is equal to 2. 3 is equal to 3. 100 equal, yeah, see? Oh yeah, I get what that's saying. Now half is equal to half. So anytime we multiply something by 1, we're going to end up getting what we started with. So let's multiply 1/2 times 1 here. Obviously we get 1/2. Now I want you to imagine 1 as a fraction, right? Anytime you do, hold that thought, I want to show you something. Okay, I found what I wanted to show you here. Let's write each of these as a fraction. We're going to skip the first one. We're going to come back to that one in a second. Go to number 2. How do you write that as a fraction? Well, 1 is shaded in, so 1 goes as the numerator. Out of how many total are there in this bar? 2. So that's 1/2. Okay. How about this one? 1 shaded in. Out of how many total? 1, 2, 3. Okay. 3 are shaded in out of 4. 1, 2, 3, 4, 5 are shaded in out of 1, 2, 3, 4, 5. 5. This one is 1, 2, 3, 4 are shaded in out of 1, 2, 3, 4, 5, 6, 7, 8. This one is 1, 2, 3, 4, 5, 6, 7, 8. 8 are shaded in out of 8. So the next thing is write each model as a fraction. Are any of the fractions equal to one another? If so, which ones? Can you tell which ones are equal to one another? I don't see any of them equal. Oh, 5 is equal to 7. That's interesting. So we could say that 5/5 is the same thing as 8/8. 5/5 equals 8/8. That's the same thing. Ooh, you know what? Let's go back to number 1. Number 1, please. Step up. Number 1. How do you write that as a fraction? How many are shaded in? 1. Out of how many boxes are there? Oops. Let's fix that. Wait a second. There we go. 1 is shaded in out of 1 box. So that, oh, you know what? That's just 1, isn't it? So 1 over 1 equals 1. 5 over 5 equals 1. 8 over 8 equals 1. Let's look at this next slide and see if this drives this point home for us. So this is 1 over 1. It's 1. This is 2 over 2 is 1. 3 over 3 equals 1. I'll pause for a second. Okay, so are you kind of detecting a little pattern here? I think you might be. So write each fraction. Which ones are equal to each other? They're all equal to each other. They're all 1. It's like we're all 1. We think we're separate. It's an illusion. We're all 1. Well, that's a philosophical, what do they call it? Metaphysics. Yeah, let's not get into that right now. It can involve math, believe it or not, in answering that question if we're all 1 or not. I mean, there is the 1, for example. That's a math thing. Okay, so how would you write 1? If you have a 1 and you want to put 1 as the bottom denominator, what do you have to put on the top? You guessed it, 1. What if you have 1 and you want to write it with 7 as the, oops, let's back that up, come here, back, and you want to have 7 as the denominator, you got to put a 7 up there. If you have 1 and you want to have 20 as a denominator, you put a 20 up there. So basically what I'm saying is any numerator over the same denominator equals 1. What if you had 1,000,000 on the bottom? What would you put on top? 1,000,000. What if you had 1,000,001 on the bottom on the denominator? You put 1,000,001 as a numerator equals 1. How about that? Okay, let's move on. So where is Mr. Hoffman going with this? This is where I'm going with this. If we want to get 4, right, as a denominator, right, how do we change 2 into 4? Well, let's multiply that by, what do we multiply 2 by to get 4? 2 times 2 equals 4. Right there, right? 2 times 2 equals 4. So what are we going to do on the top? We're going to multiply the top by 2. And what is that? That is 1 times 2 equals 2. So guess what? 1/2 is equal to 2/4. Just like 2 is equal to 2. 3 is equal to 3. Right here, remember 3 equal to 3? I'm on the left side, guys. 100 equal to 100? Because we just multiplied it by 1 in a different way. Let's try that again down here. So 1/2, what do we multiply 2 by to get 6? If you said 3, you're correct. Whatever you do on the bottom, do on the top, because that makes it 1. So 1 times 3 is 3. That means 1/2 is equal to 3/6. Let's do another one. I'm going to do the other ones. I'm going to pause and do the other one. Yeah, I just paused and I realized this would be a great Khan moment. I learned this from watching Khan Academy videos. I need you to please, I don't need you to. I highly encourage and recommend that you stop the video here and try the rest of these on your own. Okay, please do that now. Have you done it yet? Oh, yeah, you probably paused and now you're back. You're like wondering, why is Mr. Hoffman still talking? Let's just go. Hold on. Okay, take a peek and tell me what you think. Peek and think, they're not quite rhymes, but they're close, like slant rhymes maybe? I'm not sure what that's called. We have to ask your English language art teacher. Ask them, that's like a poetic kind of song, lyrical kind of thing. Okay, what are we going to use this for? We're going to use this for things like this. How can we tell greater, less than, or equal to? Well, in order to compare these, right now they're kind of like apples and oranges. We need to do a math magic trick and turn them both into apples or both into oranges, whichever you prefer. If you like apples more, turn them both into apples. If you like oranges more, turn them both into oranges. All right, so here we go. I'm going to go with oranges right now. I'm in an orange mood, so I'm going to turn this color up here at my little, you can't see what I'm doing, but it's going to turn into orange highlighter. Let's make both of these oranges because right now I have, let's see, basically we're looking for the least common multiple. Let me do that. 3 and 6. They go on for multiples go on forever. So we went the smallest one. 3, 6, 9, 12. Oh, wait a minute. As soon as I said 6, I realized that 6 is going to be common. So I'm going to turn both of these into 6s. So this is already an orange because I like orange, but this is an apple. So I got to get my little red. I don't have a red one yet. Here we go. Red, red highlighter. Yeah, we need to turn them into oranges. So let's turn that 2/3 into some kind of 6, right? So we're going to say 2/3 equals something over 6. Now, remember, I want to multiply. I'm going to give myself some room. So I'm going to take this little thing here. I'm going to say, could you just move over here, please, for a moment? Oh, that's so kind of you. Thank you, Mr. Denominator 6, Mr. Orange 6. And this is my orange. Let's make sure because I know we're going to orange. We're going to turn that apple into an orange. Here's the apple. How do we do that? Let's take multiply by 1, right? But it's a special kind of one. It's a fraction one. It's a fraction one that when we multiply 3 by something, we get 6. 3 times 2 is 6. 2 got that, man. 2 got that super. So whatever you do to the bottom, to the top, because that makes it 1. Then at the top, let's see. Here we go. Let's go this way. We're going to take 2 times 2 and get what we get. We get what you get, and you don't get upset. 2 times 2 is 4. So that means 2/3 is equal to 4/6. So now, oh, it's no longer an apple, it's an orange. Now we can compare the orange to an orange. Let's put the 4/6 there instead. So I'm going to take this original 2/3 right here. I'm going to lasso it up. I'm going to say, excuse me, we got to wrestle you up somewhere else for the moment, please, because we just turned you into, you're not supposed to really be here at all, but, we're being nice. We'll kind of pretend like, you're not a problem, move you over here. But what we are going to do is take the orange that we just made here, because that's the same thing, and put you right here. Now, oh, would you look at that? 4/6 is equal. Come on, orange, 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 orange. Calm down, Mr. Hoffman. It'll be okay. But it's not working. I can't be calm when things aren't working. There it is. Did you get that? Okay, your turn. See what you get on this one. And pause the video. I highly encourage it. Okay, so this time I did the opposite. I took this orange and since I'm just picking apples, oops, there it is, the apples. So I turned the apple into an orange. So I turned this apple here into an orange. No, I turned this orange into an apple. Oh my gosh, Mr. Hoffman, come on, don't confuse these kids any more than they already are. If you're not confused, you don't know what's going on. And if you are confused, you might not know what's going on. Uh, okay, so now let's compare the apple to apples. Let's compare this 5/12 apple to this 6/12 apple, and which one is more? Well, you guessed it. It goes this way. Wee. Next one. Try this one on your own and see what you get. Come on, show up. There you go. Okay, so for this one, remember, we're looking at lowest common denominator, which is the same thing as lowest common multiple. So what are the denominators we're working with? 4 and 8. So that's why I put the 4 here, and I made that the orange. And I put the 8 here, I made that the apple. So I'm gonna I can't pair orange and apples. I gotta have either 2 oranges or 2 apples. So we do a magic trick. Mathematicians are gonna turn this orange right here, this 2/4, into an apple. So I multiplied it by 1, really 2 over 2, which is 1. And I got 4/8. So now I can just, let's just lasso it up because it's fun to lasso things up. Put on a cowboy hat and put it right up here. Now we can compare the apples to apples. And what do we get? Is 4/8 more than 3? Oh yeah, so it's going to be A. Now, here's something. Some of you go, oh, if I know, if I just give you the problem like 1/2 and 3/4, you might just be able to put the, if it's greater than, equal to, or less than, you might go, oh, I know 3/4 is greater than, right? But what if they give you a word problem, right? And you don't know. Well, this problem actually, I think you can get it. Who ran farther? Doesn't that mean which which one of these values is greater, right? Greater. So that kind of, we don't have to do this. I just want to see if you can figure out what this problem is asking for. I think that's kind of what, if you think about it, which one of these is greater? That's really what that farther is greater. Let's go to the next one. Now, here we go. Are we looking for least common multiple, or denominator, or whatever? Or are we looking for greatest common factor? Remember the difference, factors and multiples. When we're looking for factors, they are finite. They end. They don't go on forever. Although forever starts with F, but finite means they end, right? And you know what we'll do is I'll even color code this to maybe help a little bit more. Colors help me remember things. So why won't that erase? Oh, come on, people. Not people. Come on, computer. Yay, there we go. So what I'll use factors, F, finite, they end, and then we'll green, pop in some green here. Green, 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 green. Green is for multiples, which go on forever. You know, that dot, dot, dot. So they are infinity and beyond. They go on forever. So finite stops, factors stop, multiples go on forever. What are they asking for here? Which is the first customer to receive both coupons? The first one. So think about customers for a second. Say we got the first customer, the second customer, third customer, fourth customer, fifth customer. Let's see, some places are calling it every 10th customer gets a coupon, every 12th customer gets a coupon. Oh. So first customer, second customer, third, fourth, fifth, sixth, seventh. So here we go. We got to go all the way to 10. 8, 9, 10. Here, this person gets a coupon. Now, down here, the 12th person. Wait a minute. 9, 10, 11. The 12th person gets a coupon, but the other coupon. So we have to color code these. So we'll do this coupon in green. So the 10th person gets the green, $1 coupon. Oh, so $1. 10th is $1. Then we'll do red for 12th person. Every 12th person gets $2. So our 12th person got this one. If you keep going, what's going to end up happening is we're going to go, okay, that's 12. That'd be 13, 14. How many more? Every 10th gets $1, 12. So we got to go 10 more. What's that going to be? Oh, that's going to be 20. So we can just go to 20, right? So if you're the 20th person, you're going to get a coupon. What's the next 10th person? Oh, I think I'm figuring this out. 30. And what's the next 10th person? 40. The next 10th person. These are multiples, aren't they? Yeah, we can just do multiple. They go on forever, don't they? So if we just did multiples of 10 and 12, that should get it. I'm going to clean this up. I'll be right back. Okay, so I clean this up. We've got the 10th person and is green. Oh, come on now. I just cleaned it up and I just made a mess. It sounds like my life over and over again, to infinity and beyond. Repeat, infinitum, infinitum. There's another word that sounds like that, but I'm not saying it right. Let's see, add, no? Okay, I'll come back to that later. And red is the 12th, every 12th person. So here's all of our 12th persons. So the ones that they have in common that's first, so not the 10th, not the 20th person, 30th, 40th, they all get this $1 ticket, but this 60th person gets a $1 ticket, right? So no other person here that's in our yellow, oops, come on yellow, matches. See, all these people in yellow are getting that $1 ticket, but none of those people who are getting the $1 ticket are also getting the $2 coupon. So $1 coupon and $2 coupon. But the 60th person is the first person. Is it the last person? No, if you keep going to infinity and beyond, you'll find an infinite number of people who will get the $1 and $2 coupon. Next. Sorry, this is a long video, guys. I know, we are almost done. Okay, you are the teacher distributing. Oh, I did want to point out something. Go back, 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 back. The first problem we did up here, what would be your giveaway on this problem up here that I'm showing in, let's pick another color. Oh, red, up here in red, way top. What would be your clue as to if this was lowest common multiple or greatest common factor? Look right here, it says greatest. What's the greatest number of students? So you can just take the 72 and 90 and find the greatest common factor. All right, next. Art teacher distributing supplies at a community center of art class. Every fourth student, see, this sounds like the last one, gets a tube of paint. Every seventh student, so fourth student, tube of paint. Seventh student, pack of crayons. Which student is the first? There it is again. I think I'm seeing a pattern. First person to get both paint and crayons, just like the last problem we did. If you were to write it out, 4 is multiples. It goes on and on forever, but which one is the first? All right. If it were greatest common factor, it would be the last. Which person is the last person to get it? There is no last person here because it go on forever and ever. Well, maybe we don't have enough tubes of paint and pack of crayons for everyone, so there would be some limits here, but theoretically, that's the difference between math theory and math application. And this is a little factor tree thing that you may want to take a look at. Not required. If you want to know more about how to do this factor tree stuff, which is really cool math magic, big time cool math magic stuff to have up your sleeve or in your magic hat, please email me and then we can do a special session on how to use prime factorization to find the lowest common multiple. It seems like they're opposites, right? You would think, wait a minute, you're going to use factors to find multiples? It's like insanity. But yes, with the factor tree, it's a beautiful thing, especially when you have really big numbers. Yeah, it's really helpful. So how do you feel? How do you feel about everything so far? Normally we'd be doing a little show. Oh, grit. We got to talk about grit too sometime. Oh, that looks kind of gnarly. Yeah. Ooh, it's scary. It's kind of scary when I'm putting the red over it like that. It's like, oh no, oh no. Okay, that's what's the word? I can't think of it. Okay. Anyway, there we go. That's much better. Phew, beautiful blue. Just keep swimming. Gosh, I'm so excited about all we're going to do this year. If you're still here, I'm telling you, we're in 26 minutes in this video and you're still here watching this. Hey, get out of here, kid. Go do something fun. Oh my gosh.